Hello student, very good morning to all of you. Do you remember what were we discussing yesterday? I think we were discussing about sulfonation reaction. In sulfonation reaction, we have seen how the mechanism occur. The mechanism is similar to that nitration reaction, but in the nitration mechanism involve 3 steps, whereas in a sulfonation mechanism involve as a 4 steps. So that 4 step and sulfur trioxide, how it is generated by using that one, or the kinetic isotopic effect is observed near about as a KH is equal to KD is found to be as a 2, means there somewhat kinetic isotopic effect is observed, but later on K2 is equal to K1, means again activation of energy is somewhat E activation energy is greater than that KH, so that are the slightly some differences will observe in sulfonation reaction. Otherwise, whatever point we have discussed with that nitration reaction as it is with the sulfonation reaction. Now today what we are going to discuss, let us look at the blackboard. What do you see over here? Mechanism of halogenation. This is the third most important reaction we are going to learn, because most commonly electrophilic substitution reaction we are generally studying. First one we have learned nitration, second one is a sulfonation, now is a halogenation reaction. And in the halogenation reaction means what? Again, halogenation is an electrophilic substitution reaction in which one or more hydrogen atoms of the aromatic nucleus are replaced by halogen atom is known as halogenation reaction. And halogenation, as we know that X is equal to fluorine, chlorine, bromine and the iodine, and these halogenation reaction, while studying as a mechanism, the halogenation reaction is if treated with that benzene, without catalyst there will be no reaction occur, and for that purpose, for reaction to occur, it needed or it require the Lewis acid, and the Lewis acid, the function of Lewis acid from halogenation onward, whatever rest of the reaction we are going to learn, that the Lewis acid used in those reaction, the function of those Lewis acid to generate the electrophile, that is the main function of that electrophile. In this halogenation reaction, mainly the Lewis acid such as AlCl3 or AlBr3 or FeCl3 or Fe, such Lewis acids are used in the electrophilic, in the halogenation reaction. And what is the role of that? What is the main or their primary role in the electrophilic reaction to polarize? Their primary role in the reaction is to polarize halogen molecule to produce the electrophilic halogen atom. So that is the main role they are playing over here. Without that Lewis acid, reaction does not take place, and therefore Lewis acid, they polarize the halogen molecule, and that halogen molecule is converted into as a electrophile, and once the electrophile is generated, that attacking to the benzene nucleus, and there is a formation of the uranium ion or the sigma complex, and lastly the aromatization takes place, and we will get the formation of the product, that is a halogenation. That process is known as a halogenation. Now in the mechanism the mechanism involves again as a 3-step. The mechanism of halogenation, it involves 3 steps. It involves 3 steps. 3 steps. And step number 3 step, and as we know that step number 4 is always generation of electrophile. Generation or formation of electrophile, or what we can call it as a polarization. Generation of electrophile, or we can call it as a polarization, means halogen molecule get polarized due to the presence of Lewis acid, and whatever Lewis acid we are using in this reaction are these aluminum trichloride or aluminum chloride, you can call it as aluminum bromide or iron chloride. So these are the Lewis acid used here to polarize the halogen molecule and to produce the electrophilic halogen atom. So that is the first here. Let us see here what we are taking. Suppose let us see chlorine atom, and as we know that chlorine atom get polarized and then adding as a AlCl3 over there. AlCl3, this is a chlorine molecule, and this is a aluminum chloride. It is a Lewis acid. This one is a Lewis acid, as we know that. Why it is a Lewis acid? As we know that the electron deficient species or whatever species which carries the positive charge are called as Lewis acid, and therefore here aluminum has an empty orbital, and therefore it is act as a Lewis acid. And what the Lewis acid do here, it polarize the chlorine molecule here like this Cl, then dash you can write then Cl dash AlCl3. So now here what is happening, that Cl goes along with that. Here let me show it clearly. What is happening is chlorine atom Cl positive charge over there, and then AlCl4, that is a minor charge we are getting over there. So that type of the polarization, this first step is known as a polarization or the generation of the electrophile. Means this type of the polarization occur, means here chlorine molecule get polarized due to the presence of aluminum chloride. This is a step number 1. And as usual we know that step number 2. What will be the step number 2? The step number attack of the benzene nucleus to the electrophile, and there is a formation of the rhenium ion. Second step is a formation of rhenium ion, or you can call it as a sigma complex. Formation of the sigma complex, or we can call it as a formation of the rhenium ion. Rhenium, what does mean by the rhenium ion? As we know that aromatic carbocation are known as rhenium ion. That is rhenium or carbocation of that aromatic compound. Now as we know that there is a benzene ring, we know that this is a benzene compound, and now it will be treated with Cl here positive charge dash AlCl4 minus charge over there, and now this reaction is a irreversible reaction. And now what is going to happen, and this reaction, as we know that it is a slow reaction. Slow reaction means it is termed as a RDS, rate determining step, where we can measure the exact how much time is required for the completion or for the formation of such type of rhenium ion or the sigma complex. And as I already told you that these formation of the rhenium ion, this step is a very difficult, but it is a very essential or very important, very prominent, or what we can call it as a significant of this reaction. Because in this case what is happening, the aromatic compound is changes into as a non-aromatic compound, and that's why this step is a difficult one. And now when this double bond is forming as a bond like this, what is going to happen? Here we can show for sake of convenience, one of the hydrogen atom get replaced by that chlorine atom, and we are going to get the substituted type of this rhenium ion. Let us see here, we can write like this. When this double bond is moving like this double bond and this double bond, they are as it is, I am writing as it is, and now this hydrogen atom we can write as it is. Here is a chlorine electrophile is attached over there, and that's why showing over here. And what type of the charge present on this at this corner point? There is a positive charge, right? And this is known as a rhenium ion. This is known as a rhenium ion. Or we can draw the canonical structure of this, and we can write this structure in this way. There is a positive charge, here is a hydrogen atom, here is a chlorine atom as it is, and this type of the thing is called as a sigma complex. We can call it as sigma complex, or we can say it is a rhenium ion or the sigma complex, that is a positive charge over there, and this type of the intermediate is formed in the second step, that is the formation of the rhenium ion. This is the intermediate. This intermediate is difficult to form, but it is formed due to the presence of that Lewis acid. If Lewis acid is not used in such a reaction, there will be no halogenation reaction. Remember, this is a word is a highly important or the prominent in this case. So remember that one now. And the third step, as we know that third step is a what we can call it as a abstraction of proton, or as we know that during the nitration we have seen that one step number third is similar to as a nitration. What is that? Aromatization. Third step is known as a aromatization, or we can call it as the abstraction of proton. Abstraction of proton from the intermediate, or we can say aromatization. Aromatization. This is the third step, is generally occurring in this reaction. And now what is happening here? You can take this rhenium ion as it is over here. So let us see this one. This is the rhenium ion, here hydrogen atom, here is a chlorine atom, and what is happening in this case? The rhenium ion, the basic ion formed during the first step, generation of the electrophile or the during the polarization, whatever AlCl4 minus, that is the anion formed over there. It is a basic in nature. It will abstract the proton, and it will abstract the proton from the intermediate, from the rhenium ion, and that rhenium ion, as we know that it is a non-aromatic in nature, is going to convert into as aromatic in nature, means that becomes as aromatic, and the driving force behind it is the aromatization, and therefore here AlCl4 minus, which will abstract the proton from here, from the rhenium ion, as we know that it is a non-aromatic compound. And now what is going to happen here? We are going to get the product formation of this compound, which is, we know that this is the compound chlorobenzene we got over here, and here AlCl3, that the Lewis acid which we have used in the first step is regenerated. In addition to this, HCl, that is HCl means HCl fumes are generated during this formation of the product, and the name of this compound, as we know that it is a chlorobenzene. So in this way we can prepare chlorobenzene, bromobenzene and the iodobenzene by using the same or by following the same step. So this process is known as a halogenation, and this halogenation reaction, as we know that there is no kinetic isotopic effect were not observed in this case also, because the CH and CD bond, CH bond is what we can call it as, this is the first step, and the CH bond breaking takes place in the first step, and therefore we unable to determine the rate of reaction, and therefore there will be no kinetic isotopic effect is observed in this case. In a sulfonation reaction, there is there are the 4 steps are there you can in some experiment there is a kinetic isotopic effect were observed. KH is equal to KH upon KD is found to be 2, means the reaction is exactly double in this case, and so therefore the kinetic isotopic effect were observed in sulfonation, but in this case there is no kinetic isotopic effect, and whatever energy profile diagram we have seen in case of the nitration, sulfonation, the graphical representation of the energy profile diagram remains same here in this particular case also, as we know that in energy profile diagram we are generally plotting the graph of potential energy against the progress of reaction is known as the energy profile diagram, and there you are getting as a 2 transition states are there, transition state first and the transition state 2, where there is a formation of the uranium ion or the formation of the complex, and because that uranium ion is well stabilized due to the resonance effect, and therefore even though it is a non-aromatic compound, that carbocation are well stabilized due to the resonance. So we can draw the different resonating structure, and finally we can end up with the sigma complex, or we can represent the compound like this. So in this way we have seen as a halogenation reaction is one of the important reaction in an exam. The 5 what we can call it as 3 mark question, or maybe as a 2 mark question, what is nitration reaction, explain with suitable example, or what is sulfonation reaction, explain with suitable example, or what is halogenation, explain with suitable reaction, suitable reagent. So in this way you can explain all these what we can call it as a point to point. These all are the very simple reaction as far as that electrophilic substitution reaction is considered. Suppose if you take as a bromine Br, then you can take as a Lewis acid AlC. The key point remember here, as far as while discussing such type of the electrophilic aromatic aromatic electrophilic substitution reaction, why it goes as a electrophilic substitution reaction, as we know that benzene itself, the aromatic compound itself is a nucleophilic in nature. They act as a Lewis basis, and therefore whatever reagent is added or whatever electrophile we are adding, that is, as we know that it is electron deficient in nature, and therefore the reactions are taking place over there. Now in this case Lewis acid, what is the function of Lewis acid in a aromatic compound such as halogenation? Next one we are going to learn Friedel-Crafts alkylation, Friedel-Crafts acylation. In those reactions, what is the role of Lewis acid? Remember the role of Lewis acid in a particular halogenation. It polarize means what? It generate the electrophile. The function of Lewis acid to to generate the electrophile. So that is the main point you should remember forever whenever you are discussing such type of the reaction like as a halogenation, Friedel-Crafts alkylation, or Friedel-Crafts acylation reaction. Without Lewis acid, the reaction will not going to occur. Reaction will not occur, or the reaction does not take place. And they are act as a catalyst. And what the catalyst does? Catalyst, it catalyze such type of the reaction. These Lewis acids are catalyzing these halogenation, Friedel-Crafts acylation and the Friedel-Crafts alkylation reaction, because they generate the electrophile, and at the end of the reaction, and as we know that catalyst, the role of catalyst to speed up the reaction, and at the end of the reaction they regenerate as it is, means it is regenerated whatever we are using. So we can use those catalysts again and again. So that is the main purpose or the use of that catalyst. So remember the function of catalyst in this halogenation, that is a use for the polarization of the halogen molecule to provide the electrophilic halogen atom. Remember, in this case, in a previous case we have seen chlorine atom get polarized with the Lewis acid, that is aluminum trichloride, or you can just call it aluminum chloride, and that aluminum chloride polarizing that chlorine atom, and so it is generated as an electrophile, and we are getting as a that electrophile, and once that electrophile is generated, it is easily attacked to that benzene nucleus, and we are getting as a formation of the rhenium ion, and that rhenium ion will stabilize due to the resonance, and finally the basic anion abstract the proton and aromatization back to get the substituted product. So in this way we have seen the halogenation reaction with the suitable example. In the next lecture we are going to learn about the Friedel-Crafts reaction, two Friedel-Crafts reaction mainly we are going to discuss. Let us stop today here. Thank you. Have a nice day.